All right, pre-calc, we have been doing some exponential stuff and kind of keyed in that we're definitely going to start talking about logarithms at some point. And today is the day. So here we go. You see in our blue graph here, that is our basic exponential growth. And then what we're going to do is we talk about they are inverse functions. We've said that in Algebra 2 and a couple times, just leading into it now, right? Just like multiplication and division, addition and subtraction, they're inverse functions. Exponentials and logarithmic functions are exponential or inverse functions as well. So that means that they are, if we take a look at the graph, then we have a reflection, but it's not about the x-axis or the y-axis. It's about the line y equals. And for my dear friends that are like, what? Because that happens. It's that slope of 1 with a y-intercept of 0. So this red diagonal line, and if we just take and flip this thing over back and forth, you would get the other one. So that means that they're inverses, right? This is how we check for inverse functions. But we didn't really like that check. We like the algebra check, but just make sure we point that out. So first off, we just have to change them around. And we want to write it, if it says log, then it's in log form. If it has an exponent, it's an exponential form. Okay, so I think that kind of clears it up as far as vocab. All right, this may have been, you had geometry in between here, so you may have a little gap. And here's what I do is if I want to go from log form to exponential form, yes, I can rearrange this whole puzzle, right? B is the base, X is what it's equal to, and Y is what goes here. But if it's in log form, I got like a really easy way to do this. And I don't know if I'm the only person in the world that does it, but I like it. So logs have L shape, so I'm going to draw an L shape. Okay, so that has to be the new one. 8 to the 1/3. Does that give me 2? And I know that it's correct because it is true when I rewrite it. Okay, so I'm going to draw this L shape on here again. So 10 to the -2nd is that 0.01. Remember, 0.0 is 1/100th. So yeah, that's totally true. And that works. You're like, well, that's great. No, if you're going from log form to exponential, but come on, Mr. Tilla, give me something here. Okay, draw an L shape, right? Log here. So my base is 3, -2 goes there. All right, now I agree. This one looks pretty messy when you write all that stuff in there, but after you've done it 10, 15 times, whatever it is, or even if you just see it on the first one and you picture that on the other one. So now I'm going to say log. Okay, so I want to use the base number here. I'm going to skip it equals 1/2, and I'm going to put the 5 back over here. So log base 25 of 5 equals 1/2. And you're like, hey, I didn't have to draw a box. And then just mentally, you're like, I'm going to draw this L shape anyway, just to make sure. Man, I should use a highlighter. That looks a lot better. You guys got to give me that feedback. My students, all right? Not everybody else out there trying to troll and learn how to do some pre-calc from some weird guy. All right. So what we can do is we can use this to evaluate. Now that means that this is kind of missing something important. We're saying it equals X. What is the end value? Okay, so the first thing is, now if you have a newer calculator, you can actually change this base. All right, I'm gonna bring the calculator up later, but we're gonna pretend right now that we can't do that and that you don't know the change base formula. So we deal with it just to rewrite it in exponential form and then evaluate. So here we go. 8 to what power gives me 64? Well, that's 8 to the 2nd power, and this is the way we step through it in Algebra 2. And so eventually we say X is 2. So here we say it equals X. So 3 to what power gives me 27? How did I get that? Remember, I'm drawing that L-shaped box because it's logs, right? It's logs. All right, so 3 to what power gives me 27? If you said 3, you're spot on correct again. Okay, 3 to what power gives me 3 to the square root? Square root's 1/2 power, so X equals 1/2. All right, and then we get this weird one. I have a blurb later on about it, but basically if you have log base 6, so notice that part, we're going to take 6 to the log base 6 power. So since these are inverses, we're going to drop all those. So X ends up being 11. So if you see something really weird looking, it's probably just that number. I don't think at this point we're going to layer anything different. Like I said, I have a blurb later on about it that leads you through that, especially with natural logs. All right, so on your calculator, if you use an old school calculator, right, if you got one from the school, it doesn't have any new programming. If you bought a new one, you might be able to change the base. But on your calculator, it's going to have a log button, and that one only deals with log base 10. So if you see no base at all, that has to be a 10. Okay. We're also going to deal with natural logs, right? Natural logs, ln, that means the base is e, but we don't write these in because they're known as common logs or the natural log. It's understood that's the base. So these are the ones that you could evaluate on your calculator. So if you typed in, you found it on the, I believe it's on the left-hand side. I'll pull it up here at the end, log of 10. But if I just want you to show that you understand how to change them. So 10 to what power gives me 100? Well, that's 2, right? Remember, in between, we could say this is 10 to the second. And we just want to get used to is the fact that there's no base here. So the base is 10. So we're saying 10 to 1 power gives me 10 to the, this is the first power, the fifth root, 1/5. X is 1/5. All right, and this one got flipped over. So 10 to what power gives me 1/1000. I see 3 zeros, so it's definitely the third power, but since it flipped over, it's -3. Right? Remember that rule of reciprocals. All right, so log base 10, 10, so this one is x equals 6. No big deal. All right, so the same thing happened in here. There is no base. It's actually not proper if I write an e in here, but I just want you guys to remember that the natural log implies a base of e. So this is e to what power gives me e to the 1/2, right? Because the square root is the 1/2. So x is 1/2. Okay, I'm not going to write it in this time. So we notice that this one's a little bit easier because we're not really dealing with changing that base number 10 or the 64 like we did up above. So x is 5. And here we go. The natural log has a base of e, so we're just going to get rid of these. X equals 4. But not everything has a real solution. Think about this one. Okay, so tell me 10 to what power gives me -3? What? That's not going to happen. That's not going to happen, right? Because remember, our exponentials, unless we had a translation, they're never going to be negative. Right? If I put a negative exponent in here, I can make this smaller, but I can never make it negative. Right? I can make it 1/10. I can make it 1/100th. I can do all those things, but I can never make it negative. Right? So log of a negative is a big no-no. That's going to be a no solution, okay, or no real solution. But we can solve some other problems, right? So if we start putting x in there, and that's what we're doing. We're going to use that technique of converting. That's why I didn't want you to use your calculator up above just yet. So if there's no base, remember that's a base of, okay, oh, here, let me show you on the calculator. If you forget, here's what you do. Take a look right here. Log button, look at the second function, is 10 to the x power. So if for some reason you forget this, right? I've been there. Like we're all taking like standardized tests and all sorts of stuff, so if you need a reminder, if you can use your calculator on it, just take a look there. Sometimes there is a key that helps you out. What's the base of the natural log? Second function is e to the x power. So that must be a real thing. Okay. So that means this is 10 to the third equals x. Just drawing this box on here. 10 to the third. Oh, so x is 1,000. Cool. So this one we're going to draw a box on here. So x equals 2 to the 5th. All right, so x equals, oh my gosh, you're going to try and get 2, 4, 8, 16, 32. 32? Okay. I'm going to go 32. It's early in the morning here. All right, so here's your important property. Since the natural log of x is y, and if we rearrange it, we have y, or e to the y power equals x. Why am I even reading this? You guys get it. So if we take the e to the natural log of x, we're going to end up with just x. So, it sounds really shorthand, but the idea is like we did above, we're just going to cancel those guys out. Okay, so anytime we have the natural log and e, and we can use this also in log form. We did that way up here with, right, 10, log base 10 of 6. And I thought we did this somewhere else as well. Okay, 6, log base 6 of 11. Okay, so that may be the only new thing from things you've seen in Algebra 2. Okay, so e natural log, so this is just 7. All right, the natural log, so this has a base of e. So all of this turns into 1, so that means we could actually use our log property and bring this down. So the answer is just 9. All right, how to use un calculator? All right, so I tried to preview and just show you guys what's going on here. These are common logs. So log of 34.5. Now, if I had extra stuff, I would close my parentheses, but I don't need to here. And if I was going to add multiple logs or anything like that. So 1.54 1.537. Oh, if we're going to round it, let's make it 8. So that works there. All right, does that make any sense? Kind of. Okay, so this is 10 to what power? 10 to what power gives me 35.5? Well, it's certainly not the second power, right? Because that's 100. So it's somewhere in the middle, and that's what we're trying to find here. And this is e to what power, right? E to what power gives me 23.5. So just keep in mind e is somewhere around 3. All right, so that was a natural log. I forgot what it was. 23.5. Natural log 23.5. Okay, and we're going to get 3.157. 3.157. 3.157. There it is. All right, typically with logs and natural logs, we're going to go about 3 decimal places just because 2 can sometimes be an issue for us. All right, so I have a note here. We can't use another base. Now, if you have a newer calculator, right, mine is clearly an older software version here, but you may have an option to have a little box right here. If you press log, and then I think you have to kind of scroll back to it. Notice mine won't do it, but you might get a chance to change this base in here, and that might be helpful later on in the chapter, not right now. Okay. All right. So if you're in my class, you got a little homework. If you're not in my class, thanks for tuning in. Sorry if I called you a troll, and peace.